Muscles force and body movement. Body stability. By Assistant Professor of Medical Physics Dr. Al-Arif. Equilibrium and stability. Naturally, objects tend to be stable. The stability of the body affected by many factors such as the position of the imaginary line from the center of mass, cg, of the body passing within the base, the height of the cg point from the base, the width of the base. Note, the center of mass or gravity, cg, is an imaginary point at which all the mass of the object is concentrated. Conditions for stability. 3 conditions for stability for any object. 1. The body should have a wide base. 2. Center of mass of the body, cg, must be as low as possible to the base. 3. The imaginary vertical line drawn from the cg should pass within the base, better to be in the middle of the base. The effect of the 3 conditions are shown in the figure. Types of stability. 3 types of object stability are available which depend on the width of the base and the position of the cg point with respect to the base as shown in the figure. 1. Stable object, in which the base is wide and the cg is close to the base. 2. Unstable object, in which the base is narrow and the cg is far from base. 3. Neutral object, in which the base is wide and the cg at constant distance from base even when object is moved or pushed. The main force acting on human body is the gravitational force, the weight, which is concentrated at the cg point. The weight is equal to the mass multiplied by the acceleration of gravity as in the equation. Stability of the body against the gravitational force is maintained by the bone structure, the skeleton. It gives the hard structure to the body. Fig. 1 shows that slim person more stable than fatty one since the cg line pass exactly within the middle of the base for slim person. Figure 2 shows that to maintain stability, the line of the cg point must be located between feet, the base, better in the middle of the base. Stability under external force. As in the figure, consider a horizontal force Fx applied to the shoulder of the body. This force can change the position of cg point relative to the base and tend to tipple the body. The shift happen in the center of gravity, cg, away from the pivot point A due to the applied force may increase the counterclockwise torque which tend to tipple the body. Stability can be maintained by bending the body against the force which produce clockwise torque that balance the counterclockwise torque produced by the force. Stability can also increased by spreading the legs which increase the width of the base of the body. Calculation of the toppling force. When the person tend to topples due to external forces in the figure, he will naturally bend around point A to the right. This will develop a counterclockwise torque K. If the person stays stationary, this means that his weight produce a torque W to balance the force torque. Then by putting both equations for torques as equal, we can find the amount of toppling force. Now you can follow the equations. Note, actually, a person can withstand a much greater external force without losing balance by bending in the direction opposite to the direction of the applied force. The pressure on the spinal column. Spinal column supplies the main support for the head and trunk of the body. The spinal is S-shaped to increase stability. Its bone vertebrae carry the load. Vertebrae discs between the vertebrae cushion the applied forces and pressure. In reality, the pressure on the vertebrae through the spinal remain the same even there is an increase in the mass of the body going down the spinal. This is because the area of the vertebrae increasing going down which makes pressure the same. As you know that pressure equal the force divided by the area. Increasing both force and area going down the spinal makes the pressure become nearly the same. Now you can follow the calculation below. In this slide a calculation for pressure on thoracic vertebrae is carried out knowing that the max pressure before rupturing the disc is 1100 Newton per square centimeter. Here we have a problem for you. Please try to check your result with the given answer. Good luck.